Have you ever wondered, in the quiet moments before sleep finds you, what you are actually made of? I do not mean the biological answer, the bone and muscle and blood that we can see and feel. I mean the fundamental truth of your existence. If you press your hands together right now, you feel a sensation of pressure. You feel warmth. You feel the solidity of your skin meeting skin. It feels continuous, unbroken, and substantial. Your brain tells you that you are a solid object occupying a specific place in space, interacting with other solid objects like the chair you are resting on or the device you are holding. But this feeling, this overwhelming sense of solidity that defines our entire experience of reality, is an illusion. It is a convincing, beautiful, and necessary mirage. But it is a mirage nonetheless. If we could adjust our eyes to see the universe as it truly is, if we could zoom in beyond the limits of human vision, beyond the reach of microscopes, down to the very bedrock of reality, the world you know would dissolve. The solid lines would vanish. The certainty of here and there would melt away into a shimmering haze of possibility. You would find that you are not made of solid stuff at all. You are made of emptiness. You are made of silence. You are made of a vibrating dance of energy that has been playing out since the dawn of time. Welcome to the quantum realm. This journey we are about to take is not just about understanding physics. It is about understanding yourself. It is about peeling back the layers of the everyday world to reveal the strange, ghostly, and magnificent machinery that hums beneath the surface of everything. To understand quantum physics is to accept that the universe is far softer, far more mysterious, and far more connected than our intuition allows us to believe. So, let us begin this descent together. Let us close our eyes to the macroscopic world of cars and buildings and people, and let us drift inward. Imagine we are shrinking. The world around us grows larger and larger. The walls of your room expand into continents. The fibers of your clothes become like towering forests. We are passing through the barrier of the skin, diving into the biological universe of the body. We drift past red blood cells, which look like massive rubber rafts floating in a plasma sea. We move deeper, past the twisting spiral staircases of your DNA, those ancient libraries of information written in the language of chemistry. We are getting smaller still. The molecules that make up your cells begin to look like distant planetary systems, atoms bonded together by invisible forces, holding hands in the dark. But we must go deeper. We must go to the heart of matter itself. Let us approach a single atom. For a long time, humanity believed the atom was a hard, unbreakable sphere, like a microscopic billiard ball. The ancient Greeks gave it the name atomos, meaning uncuttable or indivisible. They imagined the universe was built of these tiny, solid blocks. But as we drift closer to this single atom, perhaps a carbon atom, the backbone of life, we see that the ancients were wrong. The atom is not a solid ball. It is not a hard seed. It is a vast, open space. If you were to scale this atom up so that the outer boundary of its electrons touched the walls of a massive football stadium, the nucleus at its center, the part that contains almost all the mass, would be no larger than a single marble sitting on the 50-yard line. Take a moment to truly visualize this scale. Imagine you are standing in the highest seats of that stadium, looking down. The stadium is the atom. That tiny marble in the center is the nucleus. And everything in between, everything between you and that marble, it is emptiness. It is a void so vast that it defies comprehension. Between the electrons dancing in the nosebleed seats and the protons and neutrons huddled in the center, there is nothing, or at least nothing in the way we usually think of it. To put this in numbers that might make your head spin gently, an atom is 99.99999999999999999999999% empty space. That is a decimal point, followed by 12 nines. If you could somehow remove all the empty space from the atoms that make up the entire human race, all 8 billion of us, if you could compress us down until only the solid matter of our nuclei remained, the entire population of Earth would fit inside the volume of a single sugar cube. Think about that. All of our history, all of our wars, our love stories, our monuments, our biology, compressed into a sugar cube. That is how much of you is simply empty space. So, here is the question that should haunt you in the most beautiful way. If you are almost entirely empty space, why do you feel solid? Why, when you press your hands together, do they not simply pass through one another like two clouds of ghost-like fog? Why do you not fall through the floor? Why does the world feel so hard, so resisting, so present? The answer lies in the forces that govern the quantum world. The reason you feel solid is not because you are full of stuff, but because you are full of fields. When you press your hand against a table, you are not really touching the table. You are never really touching anything. The electrons that orbit the atoms in your hand carry a negative electric charge. The electrons that orbit the atoms in the table also carry a negative electric charge. And as we know from the simplest magnets, like charges repel. As your hand approaches the table, the electron clouds of your atoms push against the electron clouds of the table's atoms. They do not touch, they repel. The sensation of pressure you feel in your fingertips, the sensation of solidity, is actually the force of electromagnetic repulsion. It is the universe's way of saying, do not come any closer. You are floating infinitesimally above everything you think you are touching. You are hovering on a cushion of electromagnetic force. The chair you are sitting on right now, you're not actually touching it. You are suspended above it by the interplay of quantum forces levitating on a sea of subatomic interactions. We live our lives thinking we are material beings interacting with a material world, but in truth, we are fields of energy interacting with other fields of energy. The stuff is an illusion. The interaction is the reality. This realization is the first step in understanding quantum physics. It requires us to let go of our prejudice for things and embrace the reality of processes. An atom is not a thing, it is a happening. It is a constantly fluctuating performance of energy. And this performance takes place in a silence and a scale that is humbling. The size of these particles is so small that numbers lose their meaning. But let us try to grasp them anyway. A proton, the positively charged particle at the heart of the atom, is about 1 femtometer in diameter. To understand how small a femtometer is, imagine a single grain of sand. Now, imagine that grain of sand is as large as the entire planet Earth. If the grain of sand were the size of Earth, a proton would still be too small to see with the naked eye. You would need to shrink the Earth-sized grain of sand down to the size of a large auditorium to make the proton visible as a speck of dust. And yet, these infinitesimal specks are the building blocks of everything we hold dear: the iron in your blood, the calcium in your bones, the oxygen filling your lungs. It is all just a rhythmic arrangement of these tiny, vibrating entities separated by vast gulfs of nothingness. But this nothingness inside the atom is not truly empty. This is where quantum physics opens the door to a mystery even deeper than the void. In classical physics, a vacuum is simply the absence of matter. But in quantum physics, there is no such thing as a true vacuum. The empty space inside you, the empty space between the stars, is actually alive. It is seething with activity. It is filled with what physicists call quantum fluctuations. Particles and antiparticles are constantly popping into existence and annihilating each other in a frenzy of creation and destruction that happens so fast we cannot directly observe it. The silence of the void is actually a roar of energy. The emptiness is full. You are not a shell containing a void. You are a vessel containing a storm of potentiality. This concept of potentiality is the key that unlocks the quantum universe. In our macroscopic world, things are definite. Your car is parked in the driveway, or it is not. The light is on, or it is off. You are here, or you are there. We live in a world of binary certainties, but down in the quantum realm, certainty dies. In the early 20th century, as physicists began to probe the structure of the atom, they discovered something that shattered their understanding of reality. They found that subatomic particles like electrons do not behave like little distinct balls of matter. They do not have a single, definite location. Instead, they exist in a state of probability. An electron is not a point in space. It is a smear of possibilities. It is here, and it is there, and it is everywhere in between, all at the same time. It is only when we interact with it, when we measure it, that it decides to be in one specific place. Before that moment of measurement, it is a ghost. It is a wave of potential locations, rippling through the space around the nucleus. Imagine if you were like an electron. Imagine if, when no one was looking at you, you were not sitting in your chair, but rather dissolved into a cloud of probability that filled your house, your neighborhood, perhaps even the entire city. You would be partially in the kitchen, partially in the garden, partially at work, all at once. And only when someone called your name, only when the universe demanded you to be somewhere, would you suddenly snap into a single position. This sounds like magic. It sounds like a fairy tale designed to comfort us or confuse us. But it is the rigorous mathematical truth of how our universe operates at its deepest level. This is the wave-particle duality, the cornerstone of quantum mechanics, and it suggests that the solid reality we perceive is actually a collapsed state of a much more fluid and mysterious underlying reality. We are walking through a dream that has hardened into consistency. The deeper we look, the less material the material world becomes. We find that we are not made of hard matter, but of music. The subatomic particles are like notes on a violin string, vibrating at specific frequencies. Change the frequency, and you change the particle. We are a symphony of vibrations playing out against the backdrop of the cosmic void. And this brings us to a profound realization about our connection to the universe. If we are all made of the same vibrating fields, if we are all composed of the same ancient energy dancing in the void, then the separation between us is also, in some sense, an illusion. The boundaries of your skin are not the boundaries of your being. Your electron fields are constantly interacting with the fields of the air around you, with the fields of the earth beneath you, with the fields of the sunlight streaming through the window. You are continuous with the cosmos. You are a localized concentration of the same universal field that stretches to the edge of the visible universe. There is no place where you end and the universe begins. It is all one seamless garment of energy. This is not just spiritual poetry. This is the implication of quantum field theory. The fields that make up the electron in your fingertip are the same fields that make up the electrons in a distant star 1 billion light years away. It is the same ocean. You are just a specific wave. As we stand here at the threshold of this journey, looking down into the abyss of the atom, we must be willing to leave our common sense at the door. Common sense is useful for surviving on the African savanna, for knowing not to walk off a cliff or how to throw a spear, but common sense did not evolve to understand the fundamental nature of reality. To understand the quantum realm, we must be willing to accept the impossible. We must be willing to accept that something can be a wave and a particle at the same time. We must be willing to accept that observing the world changes the world. We must be willing to accept that the universe is far stranger and far more wonderful than we ever dared to imagine. So, take a deep breath. Feel the air filling your lungs. That air is a swarm of nitrogen and oxygen molecules, trillions upon trillions of them rushing into your body, exchanging energy with your blood, becoming part of you. Every breath is a quantum event. Every beat of your heart relies on the tunneling of electrons and the chemical bonds that are only possible because of quantum rules. You are a quantum machine. You are a walking, breathing mystery. And in the chapters that follow, we are going to explore this mystery together. We will walk through the double slit experiment, where reality splits in two. We will tangle with entanglement, the spooky action that Einstein feared. We will look for the cat that is both dead and alive. But for now, just rest in the knowledge of your own emptiness. Rest in the silence between the particles. You are vast, you are ancient, and you are full of light. Have you ever sat by a window in the late afternoon, watching a beam of sunlight slice through the dust motes, dancing in the air? It looks so solid, that shaft of light. It looks like a golden pillar you could almost lean against. It warms your skin with a gentle, constant heat, like a physical touch. For thousands of years, humans have looked at light and wondered what it truly is. Is it a stream of tiny invisible particles, like microscopic bullets fired from the sun? Or is it a wave, a ripple in the fabric of the universe, washing over us like the tide? The answer to this question, which seems so simple on the surface, unravels the very nature of reality. It leads us into the heart of the deepest mystery in physics, a mystery that suggests the universe does not exist in a single, definite state until it is observed. To understand where we are going, we must first understand the journey of that light hitting your hand. The light you see now began its life in the crushing, fiery heart of our star, the sun. It started as a packet of energy, born from the violent fusion of hydrogen atoms. For hundreds of thousands of years, this tiny packet of energy bounced around inside the sun, colliding with other particles, lost in a dense fog of plasma, trying to escape. It is an ancient traveler. When it finally reached the surface of the sun, it broke free and raced across the vacuum of space, traveling 93 million miles in just over 8 minutes. It crossed the cold, silent void to reach your window, to pass through the glass, and to land on your skin. And in that moment of impact, it delivered its energy to you. But what arrived? Did a particle hit you? Or did a wave wash over you? In the 17th century, two of the greatest minds in history argued over this very question. Isaac Newton, the man who uncovered the laws of gravity, believed light was made of particles. He imagined them as corpuscles, tiny, rigid things that traveled in straight lines. It made sense. Shadows have sharp edges. If light were a wave, surely it would bend around corners like sound does. But then there was Christian Huygens, a Dutch astronomer who looked at the world with different eyes. He saw light as a wave, a disturbance traveling through a medium, just as ripples travel across a pond. For 200 years, the debate simmered in the quiet halls of science. It seemed Newton had won. The world loved the idea of solid, predictable particles. But then, in the year 1801, a man named Thomas Young performed an experiment so simple yet so profound that it shattered our understanding of the universe forever. It is called the double slit experiment, and it is the gateway to the quantum world. I want you to close your eyes and imagine a room of perfect darkness, absolute velvety blackness. In the center of this room, there is a barrier, a simple wall. Cut into this wall are two narrow vertical slits side by side. They are like two tall, thin doors standing open in the dark. Behind this wall is a second screen, a detector that will capture whatever passes through the slits. Now, imagine we have a device that can fire objects, let us say tiny marbles, at the wall. We fire the marbles randomly. Some hit the wall and bounce back, but some pass through the slit on the left, and some pass through the slit on the right. If we do this for an hour and then look at the back screen, what would we see? We would expect to see two vertical bands of marks directly behind the two slits. The marbles that went through the left slit make a pile on the left. The marbles that went through the right slit make a pile on the right. This is how matter behaves. It is intuitive. It is safe. It is the world we know. Now, let us change the experiment. Instead of marbles, let us place the entire apparatus in a pool of water. We create a wave on one side of the barrier. The wave rolls forward, a wall of water moving in unison. When the wave hits the barrier, it is blocked, except for the two small slits. The water pushes through these openings, but as it exits on the other side, something beautiful happens. The water does not shoot out in straight lines. It spreads out in semicircles from each slit, like ripples from two stones dropped into a pond at the same moment. These two new waves fan out and begin to overlap. Where the crest of one wave meets the crest of the other, the water rises higher. This is constructive interference. Where the crest of one wave meets the trough of the other, they cancel each other out, leaving flat water. This is destructive interference. When these overlapping ripples hit the back screen, they do not leave two bands. They leave an interference pattern, a series of many alternating bands of high water and low water, light and dark, intense and quiet. This pattern is the signature of a wave. It is the fingerprint of fluidity. So, Thomas Young stood in his dark room and shone a beam of pure light at the two slits. If Newton was right and light was made of particles, he should see two bright bands on the back wall. If Huygens was right and light was a wave, he should see the complex interference pattern of many stripes. Young turned on the light. He waited, and there, on the back screen, painted in light and shadow, was the interference pattern. A central bright band, flanked by dark bands, then dimmer bright bands, repeating out to the edges. It was undeniable. Light was a wave. It rippled. It interfered with itself. The debate was settled. The universe was made of waves. Humanity sighed in relief. We understood. We wrapped our minds around the idea of the electromagnetic field, an ocean of energy that we swim through. But the universe was not done with us. The mystery was only sleeping, waiting for our technology to catch up to its strangeness. Fast forward to the 20th century, we had discovered that light while behaving like a wave, also came in discrete packets called photons. This was the birth of quantum mechanics. Einstein himself proved that light could knock electrons off a metal plate, as if it were a stream of billiard balls. So the question returned with a vengeance. Is it a wave or a particle? To find out, physicists decided to run the double-slit experiment again, but with a twist that sends shivers down the spine of anyone who truly contemplates it. They decided to fire the light, not as a continuous beam, but one single photon at a time. Imagine the precision of this. We are taking a single quantum of light, a solitary spark in the vast dark, and firing it at the barrier. Let us return to our mental room. The darkness is deeper now. We have a gun that fires one single photon. Click. The photon flies through the dark. It hits the detector screen at the back with a tiny flash, a single point of light. It landed in a specific spot, just like a particle would, just like a tiny marble. We fire another. Click. Another single dot appears on the back screen. We are comforted. This looks like particle behavior. We decide to run the experiment all night, firing one photon at a time, allowing them to build up on the screen one by one. We leave the room and let the machine do its work in the silence. We expect that since each photon is a single particle traveling alone, it must go through either the left slit or the right slit. There is no other photon for it to interfere with. It is alone in the universe during its journey. Therefore, when we come back in the morning, we should see two bands of dots piled up behind the two slits. Morning comes. We open the door. We look at the screen, and what we see defies all logic. What we see makes seasoned physicists weep with frustration and wonder. There, built up by thousands of individual solitary dots, is the interference pattern, the signature of a wave, the fingerprint of the ripple. But how? How can this be? Each photon was fired alone. It had no neighbors to ripple against. It had no water to push against. It traveled through the silence of the vacuum by itself. To create an interference pattern, a wave must pass through both slits at the same time, split in two, and interfere with itself on the other side. But a photon is a particle. It is a single thing. How can a single thing go through two doors at once? This is the central paradox of the quantum world. The single photon, in the solitude of its journey, somehow explores all possible paths. It behaves as a wave of probability. It does not choose the left door or the right door. It flows through both. It ripples through the left slit and ripples through the right slit simultaneously. It creates a ghost-like interference pattern with itself, deciding where it is most likely to land. And only when it hits the back screen, only when it is forced to stop, does it collapse from a wave of possibility back into a single particle of reality. It is a ghost while it travels, and a brick when it lands. This implies something staggering about the nature of existence. It suggests that until an event is recorded, until an interaction takes place, the universe does not make a decision. The photon does not have a path. It has a superposition of all paths. It is everywhere and nowhere until the moment it is caught. And it gets even stranger. Physicists thought, surely we can catch it in the act. We will put a detector, a tiny sensor, right next to the slits. We will watch which hole the photon goes through. If we see it go through the left, we will know it is a particle. So they did. They set up the watchman at the gate. They fired the photons one by one. The detector beeped. Left slit, it said. Then right slit. Then left slit. It worked. They could see the path. They could track the particle. They had forced the ghost to reveal its secret. But then they looked at the back screen. The beautiful interference pattern, the signature of the wave, was gone. In its place were two simple, boring bands, two piles of particles. By merely watching the photon, by merely asking the question, which way did you go? We destroyed the wave. The act of observation forced the universe to choose. The photon, sensing it was being watched, stopped behaving like a wave of infinite potential and snapped into the rigid behavior of a solid object. It is as if the universe is shy. It performs its magic only when no one is looking. When we turn our gaze upon it, it freezes into the solid, dependable reality we recognize. What does this mean for us? We who are made of atoms, which are made of electrons and protons, which behave just like these photons? It means that at the fundamental level, we are creatures of probability. We are woven from the same hesitation that allows a photon to be in two places at once. The solidity you feel, the certainty of the floor beneath your feet, is a result of the constant, unceasing observation and interaction of trillions of particles. The universe is constantly collapsing its own wave function, constantly solidifying itself through the web of interactions that bind us together. But in the quiet spaces, in the gaps between the interactions, the magic still holds. Think about the silence of a room when you leave it. Does the room look the same when you are not there? Quantum physics whispers a strange answer. Maybe not. Maybe, in the absence of an observer, the room dissolves into a soft haze of probability. Maybe the chair is not quite there, and the table is a little bit everywhere. Maybe the universe is a participatory drama, and we are not just the audience, but the playwrights. We create reality by witnessing it. We summon the world into existence with our gaze. This is the observer effect, and it is not just a trick of light. It is a hint that consciousness and the cosmos are linked in ways we are only beginning to understand. This double-slit experiment has been repeated with electrons, with atoms, even with large molecules called buckyballs, consisting of 60 carbon atoms. And every time, the result is the same. Matter, the stuff of you and me, behaves like a wave. It interferes with itself. It explores all possibilities. It is only the act of measurement that pins it down. This suggests that the universe is not a collection of hard objects moving through empty space, but a vast, interconnected ocean of potentiality. We are waves on this ocean. We rise, we interact, we create patterns, and eventually we subside back into the great sea of energy. As you lie there, feeling the weight of your body against the bed, remember that this weight is just a persistent interaction of fields. Remember that the light from the lamp, now perhaps turned off, has left its mark on the room. Remember that you are observing the universe simply by existing, and the universe is observing you back. In this mutual gaze, reality is born. The mystery of the double slit is not just a puzzle to be solved. It is a koan to be meditated upon. It asks us to accept ambiguity. It asks us to be comfortable with the idea that something can be both and, rather than either or. It asks us to trust that even in the dark, even when we cannot see the path, we are moving through all the open doors at once. The implications of this are vast. If a single particle can explore every possible path to its destination, what about the universe itself? Could there be other versions of history playing out in the shadow of our own? Could there be a world where the photon went left instead of right? This opens the door to the many worlds interpretation, a concept so dizzying that it deserves its own space in our journey. But for now, let us stay with the wonder of the light. Let us stay with the single photon traveling through the dark, holding the entire universe in its heart, refusing to decide until the very last moment. There is a peace in this uncertainty. It means the future is not written in stone. It is written in water. It is written in light. It is fluid, open, and alive with possibility. You are not a cog in a clockwork machine, grinding inevitably toward a fixed destiny. You are a quantum event, full of potential, capable of surprise. You are a wave of probability that has taken the form of a human being for a brief, beautiful moment. And just like the light in the experiment, you are made of something that can pass through walls, something that can be everywhere at once, something that defies the rigid rules of the solid world. So, let the concept of the interference pattern wash over you like a gentle tide. Visualize those ripples spreading out, crossing each other, creating peaks of joy and troughs of quiet. Imagine your own life as one of those ripples, interacting with the ripples of the people around you, creating a complex, beautiful pattern on the canvas of time. We are all interfering with each other in the best possible way. We are all part of the same great wave, and as we drift deeper into this quantum dream, as we prepare to look even closer at the fabric of reality, remember that the act of looking changes everything. You have changed just by listening. You have collapsed a new possibility into existence. The silence of the quantum realm is not empty. It is pregnant with expectation. It is waiting for you. It is waiting for your attention to bring it to life. And as we move forward, we will see that this connection between the observer and the observed is just the beginning. We will find that particles can be linked across vast distances, communicating faster than the speed of light, defying the very concepts of space and time. We are heading toward entanglement. We are heading toward the spooky action at a distance. But that is a story for another moment. For now, rest in the particle and the wave. Rest in the light that is both solid and spirit. Rest in the knowledge that you are a mystery that the universe is telling to itself. Have you ever felt a sudden, inexplicable connection to someone you love, even when they were thousands of miles away? A mother waking up at the exact moment her child is in distress across the ocean? A set of twins who seem to finish each other's sentences, or feel each other's pain despite living separate lives? We often dismiss these moments as coincidence, or perhaps we romanticize them as spiritual bonds that transcend the physical world. We tell ourselves that in the cold, hard universe of matter and laws, true connection requires proximity. We believe that to touch someone, you must be near them. We believe that information, like a letter or a radio wave, must travel across the space between us, taking time to arrive. This is the intuitive law of the playground. You cannot push a swing if you are not standing behind it. You cannot whisper a secret if the other person is not close enough to hear. Distance, we assume, is the great separator. It is the vast, silent gulf that keeps things apart. But what if I told you that distance is an illusion? What if I told you that at the deepest level of reality, in the basement of the universe where the quantum machinery hums, there is no such thing as separation? What if two objects, once they have touched, are never truly apart, no matter how far they travel? Welcome to the phenomenon that Albert Einstein called spooky action at a distance. Welcome to the mind-bending reality of quantum entanglement. To understand this, we must go back to the idea of the particle, the tiny electron or photon we met in the previous chapters. Imagine we have a process that creates two electrons at the exact same moment, born from the same burst of energy. Because of the laws of conservation in the universe, the rules that say everything must balance out, these two electrons are born with opposite properties. Let us talk about a property called spin. Now, do not imagine the electron literally spinning like a tiny spinning top, although the name suggests it. In the quantum world, spin is just an intrinsic magnetic property, a state of being. It can be either spin up or spin down. It is a binary choice, like heads or tails. Because these two electrons were born together as a pair, the universe demands that their total spin adds up to 0. If one is spin up, the other must be spin down. They are like a pair of gloves, a left and a right. You cannot have two left gloves from a pair. If you find the left one, you know instantly that the other is the right one. But here is where the quantum world departs from the world of gloves and shoes. In our daily life, if you put a left glove in a box and send it to Antarctica, and the right glove in a box and send it to the moon, the gloves are defined from the start. The one in Antarctica was always the left glove. You just did not know it until you opened the box. The state was hidden, but it was fixed. In the quantum world, however, the electrons are not fixed. Remember the lesson of the double slit. Until a particle is measured, it exists in a state of superposition. It is a cloud of probability. It is both spin up and spin down at the same time. So, when our two electrons fly apart, they are not a left glove and a right glove. They are two undefined, shimmering ghosts, each one possessing the potential to be either up or down. They are spinning in a twilight of indecision, and crucially, they are entangled. They share a single mathematical existence. They are not two separate particles anymore. They are one single quantum system that just happens to be stretched across space. Let us perform a thought experiment. We take one of these entangled electrons and we keep it here on Earth, in a quiet laboratory in a basement in Switzerland. We take the other electron and we carefully transport it to a laboratory on a planet orbiting the star Proxima Centauri, 4 light years away. That is about 23 trillion miles, a distance so vast that even light, the fastest messenger in the universe, takes 4 years to cross it. So now we have our system stretched across the stars. One part is here, one part is there. Both are in a superposition of spin up and spin down. Neither has decided what to be. They are waiting. Now, the physicist on Earth decides to measure her electron. She sets up her detector. She forces the universe to answer the question, are you up or are you down? The detector clicks. The wave function collapses. The electron snaps into reality. Let us say it turns out to be spin up. In that exact nanosecond, no, instantaneous with that moment, the electron on Proxima Centauri collapses too. It becomes spin down. It does not matter that it is 23 trillion miles away. It does not matter that no signal could have traveled between them. The moment the Earth electron decided to be up, the Proxima electron knew it had to be down. The connection was instant. It was faster than light. It was immediate. This is the result that terrified Einstein. He hated it. He spent the latter part of his life trying to disprove it. To Einstein, the speed of light was the cosmic speed limit. Nothing, absolutely nothing, could travel faster than light. If the electron on Earth communicated with the electron on Proxima Centauri instantly, it would break the fundamental laws of relativity. It would mean that cause and effect were unhinged. It would imply a universe where things happen without a mechanism to explain them. He called it spooky because it defied the realism of classical physics. He argued that quantum mechanics must be incomplete. He proposed that there must be hidden variables, secret instructions written inside the particles that we just could not see yet, telling them what to do from the start, just like the gloves in the boxes. For decades, this was a philosophical debate. Was the universe local, meaning things only affect their immediate surroundings? Or was it non-local, meaning things could be connected across vast distances instantly? It seemed impossible to test. But in 1964, a physicist named John Bell came up with a brilliant mathematical theorem. He found a way to test if there were hidden variables or if the spooky connection was real. He proved that if the world was made of hidden variables like gloves, the correlations between measurements would follow a certain limit. But if the world was truly quantum and entangled, the correlations would break that limit. It was a clear line in the sand. It took another 20 years for technology to catch up. But in the 1980s, a French physicist named Alain Aspect finally performed the experiment. He measured entangled photons separated by enough distance that no signal traveling at the speed of light could possibly connect them during the measurement. The results were conclusive. Einstein was wrong. The hidden variables did not exist. The spooky action was real. The universe is non-local. Let that sink in for a moment. The universe is non-local. This means that space, the distance between things, is not fundamental. It means that two particles can be separated by the width of the entire observable universe, billions of light years, and yet still behave as a single entity. If you tickle one, the other laughs. If you measure one, the other responds. They do not need to send a radio signal. They do not need to shout across the void. They are connected by a thread of existence that transcends space and time. They are, in a very deep sense, the same object. Now, here is where the poetry of physics meets the philosophy of existence. If entanglement is real, and thousands of experiments have proven it is, then what does that say about us? Think back to the very beginning of the universe. Think back to the Big Bang 14 billion years ago. At that singular moment of creation, all the matter and energy in the universe was concentrated into a point smaller than a single atom. Every electron, every proton, every neutron that now makes up the stars, the galaxies, the planets, and your own body, they were all crushed together in a hot, dense unity. They were all interacting. They were all entangled. As the universe exploded outward, expanding faster than the mind can comprehend, these particles flew apart. They formed hydrogen clouds. They collapsed into the first stars. They were forged into heavier elements in supernova explosions. They gathered to form the earth. They cycled through rocks, through water, through plants, and eventually they became you. But if they were entangled at the start, does that connection ever truly break? In the strict mathematical sense, interactions with the environment can scramble entanglement, making it hard to detect. This is called decoherence. It is why we do not see people walking through walls or telepathing with their cousins on Mars. The delicate quantum states get muddy in the noisy, warm world of biology. But the fundamental link, the deep, underlying unity, that has never been disproven. There is a very real scientific argument to be made that everything in the universe is, to some degree, entangled with everything else. The atoms in your left hand are entangled with the atoms in a star in the Andromeda galaxy. The electrons in your heart are dancing in a subtle, invisible rhythm with the electrons in the ocean of a distant world. We are not isolated fragments moving through a lonely void. We are parts of a single, vast, breathing quantum system. The separation between me and you between here and there is a macroscopic illusion. It is a convenient fiction that helps us navigate the world of survival, but it is not the ultimate truth. When you look at the night sky, you are not looking at a collection of foreign objects. You are looking at a part of yourself that has drifted away. You are looking at the rest of the quantum wave function that you belong to. This is the scientific basis for a feeling that mystics and poets have spoken of for millennia, the feeling of oneness. We are one, not metaphorically, but physically. We are woven from the same fabric, connected by threads of quantum correlation that can never be cut. The universe is a single, seamless garment, and we are just patterns on the cloth. This changes how we think about loneliness. How can you be lonely if you are physically connected to everything that exists? How can you be alone if the very atoms of your body are singing in harmony with the atoms of the ancient cosmos? The silence of your room is not empty. It is filled with the silent, instant hum of connections stretching to the edge of time. You are anchored to the universe. You are held by it. And this phenomenon of entanglement is not just a ghost story. It is becoming the foundation of our future technology. Scientists are now building quantum computers that use entangled particles to perform calculations impossible for normal computers. They are building quantum internet networks that are unhackable, because to intercept the message would be to break the entanglement and destroy the information. We are learning to harness the spooky action. We are learning to use the threads of the universe to weave a new kind of information age. But even as we build these machines, the mystery remains. Why is the universe built this way? Why does it allow for this instant connection? Some physicists suggest that entanglement is actually what creates space and time itself. They propose that the geometry of the universe, the very fabric of a space-time that gravity warps, is stitched together by billions upon billions of entangled pairs. Without entanglement, space might not exist. The universe might just be a chaotic soup of isolated points. It is the connection, the relationship between particles, that weaves the tapestry of reality into a coherent whole. Relationship is fundamental, connection is primary. Things do not exist in isolation. They exist only in relation to one another. So, as we drift deeper into this quantum journey, let us carry this thought with us. We are creatures of connection. We are built of particles that yearn for their partners. We are stardust that has not forgotten where it came from. The spooky action is not spooky. It is intimate. It is the universe refusing to let go of itself. It is the memory of the Big Bang, written in the spin of the electron. In the next chapter, we must confront an even stranger paradox. We have talked about particles being in two places at once, and particles being connected across the universe. But what happens when we try to apply these rules to the macroscopic world? What happens when we put a living creature into the quantum box? We are going to meet a very famous and very unfortunate imaginary cat. We are going to ask the question, can something be dead and alive at the same time? We are going to explore the border between the quantum world and the world of our daily lives, and ask why we do not see tables and chairs being in two places at once. We are going to meet Schrodinger's cat. But for now, let the idea of entanglement settle in your mind like a warm blanket. Visualize the invisible threads of light connecting you to the room, to the earth, to the stars. Visualize the web of connection that holds the universe together. You are not a solitary observer on a lonely rock. You are a node in a cosmic network of being. You are plugged in. You are connected. And in the silence of the quantum realm, You are never, ever alone. The universe is holding your hand across the vastness of space, faster than light, instant and eternal. Rest in that connection. Rest in the oneness. Rest in the spooky, beautiful, unbreakable bond of the quantum world. Have you ever woken up in the middle of the night, in that strange, hazy twilight between deep sleep and full wakefulness, and felt like you were not quite a person yet? For a few fleeting seconds, you do not remember your name. You do not remember where you are. You do not remember your history, your job, your worries, or your loves. You are just a point of awareness floating in the dark. In that moment, it feels as if you could be anyone. It feels as if you could step out of bed and walk into a different life, a different city, a different timeline. You are pure potential. You are a ghost waiting to be poured into a body. But then, the alarm clock glows red, or a car passes on the street outside, or your own heartbeat thuds in your ears and the spell is broken. The memory of who you are rushes back in. The world solidifies. You are you again, trapped in a single narrative. That fleeting sensation of being everything and nothing at once is perhaps the closest we can get, emotionally, to the most famous and paradoxical thought experiment in the history of science. We are about to step into a hypothetical box. We are about to confront the absurdity of the quantum world when it bleeds into our own. We are about to meet a creature that has haunted physics for nearly a century, Schrödinger's cat. To understand why this cat exists, or does not exist, we must return to the year 1935. Quantum mechanics was young, wild, and incredibly successful. The equations worked. They predicted the behavior of atoms with terrifying precision. But the implications of those equations were driving the older generation of physicists, including Albert Einstein and Erwin Schrödinger, absolutely mad. They could not accept the idea that reality was fuzzy. They could not accept that a particle did not have a defined state until it was measured. They believed that the universe had to be objective, that truth existed whether we looked at it or not. Schrödinger, an Austrian physicist, who had actually written the wave equation that is the foundation of quantum mechanics, wanted to show just how ridiculous the prevailing interpretation was. He wanted to construct a scenario so absurd that it would force everyone to admit that something was missing from the theory. He did not intend for the cat to be taken literally. He intended it as a joke, a reductio ad absurdum, a way to say, look, if you believe this, you must also believe in zombie cats. So, let us build the box. Imagine a steel chamber. It is perfectly sealed. No light can get in, and no sound can get out. It is isolated from the rest of the universe. Inside this box, we place a Geiger counter, a device that detects radiation. We place a tiny amount of a radioactive substance, perhaps a speck of uranium. The amount is so small that there is exactly a 50-50 chance that one of the atoms will decay within the next hour. It is a perfect coin toss, but a quantum coin toss. If an atom decays, it releases a particle. The Geiger counter detects this particle and clicks. We connect the Geiger counter to a mechanical relay. If the counter clicks, it releases a hammer. Under the hammer, we place a flask of hydrocyanic acid, a lethal poison. If the hammer falls, the flask shatters, the poison is released into the air of the box. And finally, into this Rube Goldberg machine of death, we place a living, breathing cat. We seal the door. We wait for 1 hour. Now, we must ask the question, what is the state of the cat inside the box? According to our common sense, the answer is simple. The cat is either alive or dead. The atom either decayed or it did not. It is one or the other. We just do not know which one until we open the box. It is a matter of ignorance, not reality. The cat knows if it is alive. The universe knows. We are just waiting to catch up. But according to the strict interpretation of quantum mechanics, the interpretation that Schrodinger was mocking, this is not the case. In the quantum world, the radioactive atom is in a state of superposition. It is a wave function that contains both the possibility of decayed and not decayed simultaneously. It has not chosen yet. Because the atom is entangled with the Geiger counter, the counter is also in a superposition. It is both clicked and not clicked. Because the counter is entangled with the hammer is both fallen and raised. Because the hammer is entangled with the flask, the poison is both released and contained. And because the poison determines the fate of the cat itself becomes entangled with the quantum system. Until the moment we open the box and make an observation, the cat is mathematically described as a superposition of states. It is not alive. It is not dead. It is alive and dead. It is a blur of biological existence and non-existence. It is a ghost cat suspended in a twilight reality where contradictory truths coexist in the same space. This image is disturbing. It goes against everything we know about the world. In our world, things are distinct. A cup is broken or whole. A light is on or off. A heart is beating or still. We do not see blurred realities. So, why did Schrodinger propose this? He wanted to force us to ask, where does the quantum world end and the classical world begin? An atom can be in two states at once. We have proven that in the lab. A molecule can be in two states at once, but a cat? A cat is made of trillions upon trillions of atoms. If every single atom in the cat is subject to quantum laws, why isn't the cat? At what level of complexity does the fuzziness of the quantum world snap into the solidity of the macroscopic world? For decades, this question remained a philosophical embarrassment. Physicists would say, shut up and calculate. The math worked, so they ignored the cat. But in recent years, we have developed a better understanding of why we do not see zombie cats walking down the street. The answer lies in a concept called decoherence. Remember the box? We said it was perfectly isolated. But in the real world, nothing is perfectly isolated. The universe is noisy. It is messy. It is crowded. Even in the deepest vacuum of space, there are stray photons from the Big Bang zipping around. There are gravitational waves. There are air molecules bouncing against the steel walls of the box. Every time a single particle from the outside environment hits the box, or hits the cat, or hits the Geiger counter, it acts as a tiny measurement. It is a tiny observer asking, where are you? The environment is constantly, aggressively observing everything within it. It is constantly bullying the quantum systems to declare their state. This process is called decoherence. It is the loss of quantum coherence, the loss of the magic superposition, due to interaction with the surroundings. The reason you do not see a cat in a superposition is that the air in the box is measuring the cat billions of times a second. The heat radiating from the cat's body is measuring its position. The light bouncing off its fur is measuring its state. The universe is a relentless paparazzi. It is constantly snapping photos of reality, forcing it to be defined. For a large object like a cat or a human or a chair, the quantum superposition lasts for such an infinitesimally short time, fractions of a fraction of a nanosecond, that it is effectively instantaneous. The superposition collapses before it can ever be noticed. We are too big, too warm, and too messy to be quantum ghosts. We leak information into the universe constantly. We leave a trail of interactions wherever we go. To be truly quantum, to maintain the magic of being in two places at once, you must be perfectly isolated. You must be cold. You must be silent. You must be hidden from the prying eyes of the environment. But this explanation, while comforting, does not solve the mystery entirely. It just pushes it back a step. It tells us why we don't see the superposition, but it doesn't tell us what happens when the measurement is finally made. When the box is opened, or when the environment forces a decision, does the universe randomly pick one option? Does it roll a die and say, okay, this time the cat is alive? This is the Copenhagen interpretation, the standard view. It says that reality is fundamentally random. God plays dice. There is no reason why the cat survived. It just happened that the probability wave collapsed that way. But there is another possibility, a possibility that is even stranger than the dead-alive cat. It is a possibility that was laughed at when it was first proposed in the 1950s by a graduate student named Hugh Everett, but which is now taken seriously by many of the world's leading physicists. It is called the many worlds interpretation. Everett looked at the math of Schrodinger's equation and said, wait a minute. The equation never says the wave collapses. The equation never says the other possibility disappears. It says the wave continues to evolve. According to many worlds, when you open the box, you do not force the universe to make a choice. You do not kill one possibility to save the other. Instead, the universe splits. At the moment of measurement, reality branches into two distinct, separate timelines. In one universe, you open the box and find a living, purring cat. You breathe a sigh of relief. You pick it up and pet it. In another, equally real universe, separated from you by a thin veil of probability, you open the box and find a dead cat. You weep. You bury it. Both outcomes happen. Both histories are true. But they happen to two different versions of you. This implies that there is no such thing as a unique you. There is an infinite branching tree of yous, exploring every possible outcome of every possible quantum event. Every time an electron goes left instead of right, the universe splits. Every time a radioactive atom decays or doesn't decay, a new world is born. We are walking through a multiverse of infinite variety, blind to the millions of ghost selves walking beside us. In this view, Schrodinger's cat is always alive, somewhere, and it is always dead somewhere else. The paradox is resolved not by collapse, but by abundance. The universe is too rich to choose just one story. It tells them all. This thought is both terrifying and exhilarating. It suggests that every regret you have, every what if, every path not taken, has been taken. There is a version of you who said yes instead of no, a version of you who took the job in Paris, a version of you who missed the bus and met the love of your life, a version of you who is reading the script, and a version of you who scrolled past it. We are not single melodies. We are a choir. We are a symphony of possibilities playing out across an infinite dimensional space. But let us return to the cat in the box before the box is opened, before the split, before the collapse. Let us stay in that moment of suspension. There is something profoundly human about that state. We often feel like Schrodinger's cat in our own lives. We feel trapped in situations where the outcome is uncertain, where we are suspended between two futures, waiting for a medical diagnosis, waiting for a text message, waiting for an acceptance letter. In those moments of waiting, we are in a kind of psychological superposition. We hold the fear of the worst-case scenario and the hope of the best-case scenario in our minds simultaneously. We live in both futures at once, And perhaps, in a way, we are the ones in the box. The box is our own perception. We are locked inside our skulls, receiving signals from the outside world, trying to make sense of a reality that is fundamentally ambiguous. We are constantly collapsing the wave function of our own lives, with our choices, with our attention, with our beliefs. We are the architects of our own reality, collapsing the chaos of potential into the order of experience. Schrödinger's thought experiment was meant to show the limits of quantum mechanics, but it ended up revealing its boundless mystery. It forced us to confront the fact that the world is not what it seems. It forced us to admit that the solid, reliable reality of tables and chairs is an emergent property, a collective illusion sustained by the constant chatter of atoms. It forced us to look at a cat and see a cosmos. As you lie here, safe in your bed, imagine the atoms of your body. They are not dead matter. They are vibrating, decaying, interacting. There are carbon-14 atoms in your bones right now that are radioactive. At any moment, one of them could decay. At any moment, a microscopic quantum event could trigger a change in your DNA, a change in a neuron, a change in a thought. You are a walking box of probabilities. You are a collection of trillions of dice being rolled every microsecond. And yet, here you are, stable, whole, alive. The miracle is not that the cat can be both dead and alive. The miracle is that we are alive at all. The miracle is that out of the chaotic, swirling storm of quantum uncertainty, a coherent consciousness has emerged. You are a lighthouse of stability in a sea of probability. You are the observer who opens the box every morning when you wake up. You collapse the dream into the day. You decide, by your very existence, that the universe is real. So, the next time you see a cat sleeping in a sunbeam, looking like a puddle of fur, neither fully liquid nor fully solid, give it a nod of respect. It is the mascot of the mystery. It is the guardian of the threshold. It reminds us that reality is not a fixed stage, but a performance. It reminds us that until we look, the world is everything it could possibly be. And even after we look, the mystery remains, hiding just behind the curtain of the atoms, waiting for us to close our eyes again. In the silence of your room, you are safe from the hammer and the poison. But you are not safe from the wonder. You are entangled with the air you breathe. You are a wave function spreading out into the night. You are a possibility waiting to happen. And as we prepare to move even deeper, to look at what this all means for the nature of time itself, remember that in the quantum world, the past and the future are not as separate as you think. We are about to challenge the arrow of time. We are about to ask if the future can influence the past. But for now, just be. Be the observer. Be the witnessed. Be the cat purring in the dark, alive and full of secrets. Have you ever wished you could turn back the clock? Have you ever laid awake at 3 a.m, replaying a conversation from 10 years ago, wishing you had said the other thing, wishing you had taken the left turn instead of the right? We live our lives trapped in the arrow of time. We feel it as a relentless current, dragging us from the past, which is fixed and frozen in memory, toward the future, which is open and unknown. We believe with every fiber of our being that the past causes the present, and the present causes the future. You drop a glass, and then it shatters. You never see the shards leap up from the floor and reassemble themselves into a whole cup. The arrow only points one way. The past is a locked room. The future is an open field. This is the law of our existence. It is the source of our nostalgia, our regret, and our hope. But what if I told you that in the quantum world, This law is merely a suggestion. What if I told you that the particles that make up your body do not experience time the way you do? What if, under the right conditions, a choice made in the future can reach back and rewrite the past? We are about to enter the most mind-bending territory of all. We are about to explore the delayed choice quantum eraser experiment, a scientific setup that challenges the very linear nature of time itself. To understand it, we must return to our old friends, the photon and the double slits. Remember the rule. If we know which path the photon took, it behaves like a particle, no interference. If we do not know, it behaves like a wave, interference. The act of knowing kills the wave. But what happens if we decide to find out which path it took after it has already hit the screen? Imagine a photon approaching the double slits. It passes through. But this time, right after the slits, we use a special crystal to split the photon into two entangled twins. Let us call them the signal photon and the idler photon. They are entangled, meaning they share the same existence. The signal photon goes straight to a detector screen, just like in the original experiment. Its journey is short. It hits the screen and makes a dot. This event happens first. It is now part of history. The dot is there. The idler photon, however, is sent on a much longer journey through a maze of mirrors and detectors. It travels away from the screen. We can set up this maze so that the idler photon arrives at its detectors after the signal photon has already been recorded. Here is the twist. In the maze of the idler photon, we have a choice. We can place detectors that will tell us exactly which slit the original photon came from. This preserves the which path information. Or we can place a scrambler, a beam splitter, that erases that information, making it impossible to know which slit it came from. This is the quantum eraser. The crucial point is that we make this choice, to measure or to erase, after the signal photon has already landed. The signal photon has finished its journey. Its fate should be sealed. It has already appeared on the screen as a dot. So, we run the experiment. We let the signal photons hit the screen. They form a jumbled mess of dots. Then, billions of nanoseconds later, we decide what to do with the idler photons. If we choose to measure the path of the idler photons, and then go back and look at the corresponding signal photons on the screen, we find they formed a clump, a particle pattern, no interference. This makes sense. We knew the path. But if we choose to use the eraser, if we destroy the information about which path they took, and then look at the same signal photons that landed before we made that choice, we find something impossible. We find that those specific signal photons formed an interference pattern. They behaved like waves. Let me repeat that, because it defies all human logic. The signal photon hits the screen. It has to decide, am I a particle or a wave? But the decision depends on whether we know its path. But we have not decided whether to know its path yet. We won't make that decision for another few moments, or in principle, another million years. Yet, somehow, the photon on the screen knows what we are going to do in the future. It behaves as a wave if we will erase the information, and it behaves as a particle if we will keep the information. It is as if the photon waited. It is as if the future decision reached back in time and told the photon how to land. The effect, the pattern on the screen, happened before the cause, the decision to erase. This suggests a universe where the past is not written in stone. It suggests that the history of a quantum event is not real until it is fully observed, even if that observation happens in the future. John Wheeler, the great physicist who dreamed up a cosmic version of this experiment, said it best. The past has no existence except as it is recorded in the present. He imagined a photon coming from a quasar billions of light years away. It passes a galaxy that acts as a gravitational lens, bending the light. The photon can go left or right around the galaxy. It travels for billions of years. Finally, it reaches Earth. We point a telescope at it. We can choose to look at the whole image, wave, or zoom in on one path, particle. Our choice now on Earth determines whether that photon traveled as a wave or a particle for the last billion years. We are, in a very real sense, participating in the creation of the history of the universe. We are reaching back to the Big Bang and refining the story. This is retrocausality. It is the idea that the arrow of time is double-headed. Information can flow from past to future, but quantum mechanics allows for a subtle, ghostly influence from future to past. It does not mean you can go back and kill your grandfather. The paradoxes of time travel are protected by the fuzziness of the quantum state. You cannot send a winning lottery number back in time, but you can change the character of the past. You can change whether it was a wave or a particle. You can change its definition. What does this mean for us, the conscious observers floating in this river of time? It suggests that our perception of time as a strict, linear flow is a biological illusion. We evolved to see time this way because it helps us survive. We need to know that the lion is coming before it eats us. But the universe does not share our anxiety. To the universe, time might be more like a block of ice, a block universe, where the past, present, and future all exist simultaneously. They are all just coordinates on a map. The dinosaur, the Roman soldier, you reading this now, and your great-great-granddaughter on Mars. They are all equally real, all frozen in the crystal of eternity. We are just a spotlight of consciousness moving through the block, illuminating one slice at a time and calling it now. If this is true, then the past is not gone. It is just down the road, and the future is not waiting to happen. It is already there, waiting for us to arrive. The delayed choice, quantum eraser, hints that the structure of this block is woven together by threads of logic that transcend sequence. It tells us that the story of your life is not just being written forward, it is being edited backward. Every time you remember an event, every time you recontextualize a trauma, every time you find new meaning in an old pain, you are doing something akin to the quantum eraser. You are changing the which path information of your own history. You are changing the interference pattern of your soul. Think about a moment of regret, a moment you wish you could erase. In the classical world, that moment is a heavy brick carried in your pocket. It happened. It is a fact. But in the quantum world, facts are fluid. They depend on the measurement. Perhaps, by changing how you measure that moment now, in the present, you change its quantum nature. You change it from a particle of pain into a wave of wisdom. You change the way it ripples into your future. The past is not a dead weight. It is a living resource. It is an idler photon waiting for you to decide how to observe it. This connects beautifully to the concept of the eternal now. If past, present, and future are entangled, then the only moment that truly exists for an observer is the moment of observation. The now. In the now, you hold the power of the eraser. You hold the power to collapse the wave function. All of history is anchored in this present breath. The light from the stars, the decay of the atoms, the firing of your neurons. It all culminates in this singular, exquisite point of awareness. You are the needle on the record player of the cosmos, bringing the music to life. But there is another layer to this mystery. if the future can influence the past, does that mean our destiny is already written? If the idler photon's future detector setting changes the signal photon's past behavior, does that mean the universe is deterministic? This is a fierce debate. Some argue it proves superdeterminism, that everything, even our choice to measure, was scripted at the Big Bang. Others argue it proves that time is simply a construct of entropy, a measure of disorder, and has no fundamental reality. Let us return to the image of the river. We usually imagine ourselves in a boat, rowing furiously against the current, or drifting helplessly with it. But quantum mechanics suggests we are not in the boat. We are the river. We are the water, the banks, and the ocean all at once. The water at the source knows about the water at the mouth. The beginning implies the end, and the end implies the beginning. In T.S. Eliot's words, "In my end is my beginning." The quantum universe is a circle, not a line. It is a snake eating its own tail, the ancient symbol of the Ouroboros. This circularity offers a profound comfort. It means that nothing is ever truly lost. The moments of your childhood, the laughter of loved ones who have passed, the golden afternoons of summer, they are not gone. They are still there in the block universe, shining just as brightly as they did when your consciousness was focused on them. They are permanent fixtures in the architecture of reality. We just cannot see them from where we are standing, just as you cannot see New York when you are in London. But you know New York still exists. The past is a place, and in the quantum realm, the doors between places are never fully locked. So, as you drift toward sleep, let go of the anxiety of time. Let go of the pressure of the ticking clock. The clock is a mechanical toy we built to measure a ghost. It is not the truth. The truth is the timeless field. The truth is the entangled web where cause and effect dance in a circle. You are an eternal being, experiencing a temporary illusion of sequence. You are a quantum traveler, moving through a landscape of moments that are all equally precious, all equally now. Feel the freedom of that. You are not running out of time. You are made of time. You are the fabric in which the events unfold. And if the future can heal the past, then there is always hope. There is always the possibility that a future version of you, wise and kind, is reaching back right now, sending a signal to your present self, erasing the sharp edges of your pain and turning them into a beautiful interference pattern. Maybe that feeling of intuition, that sudden clarity, is just you from tomorrow, whispering to you from yesterday. In the next chapter, we are going to look at another impossibility. We have dealt with things being in two places, things being connected across space, and things moving backward in time. Now, we must ask, can a ghost walk through a wall? Can a particle face an impossible barrier, a mountain it does not have the energy to climb, and simply vanish and reappear on the other side? We are going to explore quantum tunneling. We are going to learn why the sun shines, why you exist, and why walls are not as solid as they seem. We are going to learn that there are no closed doors in the universe, only probabilities waiting to be tested. But for this moment, rest in the timeless. Rest in the block of crystal. Rest in the knowledge that your life is a complete, beautiful work of art, already painted on the canvas of eternity. The light that hits your eye is ancient, and the thought you just had is new, and they are dancing together in the same glorious instant. You are the eraser and the scribe. You are the keeper of the time. You are the silence in the clock. Have you ever faced an obstacle in your life that felt absolutely insurmountable? A problem so large, a barrier so high, a door so tightly locked that you knew with a cold certainty of logic that you did not have the energy to overcome it. We have all stood at the foot of these metaphorical mountains. We look up at the peak, shrouded in clouds, and we calculate our strength. We know our limits. We know that if we try to climb, we will fail. We will slide back down. Gravity is a law, and weakness is a fact. In the physical world, walls are absolute. If you throw a tennis ball at a brick wall, it will bounce back. It will never, not in a billion years, simply pass through the bricks and appear on the other side. If you roll a boulder up a hill and you run out of energy halfway up, the boulder rolls back down. It does not magically teleport to the summit. This is the rule of classical mechanics. Energy is currency, and if you cannot pay the toll, you cannot cross the bridge. The barrier is the end of the story. But what if I told you that this rule, which governs our roads and our walls and our tennis balls, is a lie? What if I told you that deep inside the machinery of the universe, there is a loophole, a secret passageway that allows the impossible to happen? What if I told you that the reason you are alive right now, the reason the sun rises every morning to warm your face, is because particles routinely cheat the laws of energy? They do not climb the mountain. They do not break the wall. They simply vanish from one side and reappear on the other, as if the barrier did not exist at all. Welcome to the ghost world. Welcome to quantum tunneling. To understand this miracle, we must return to the image of the wave. Remember that in the quantum realm, a particle is not a hard, distinct point. It is a probability cloud. It is a wave function that spreads out across space. When a quantum particle, like an electron, approaches a barrier, let us say a thin sheet of metal or a force field of electrical repulsion, it behaves like an ocean wave hitting a seawall. Most of the wave bounces back. Reflection. That is what we expect. But the mathematics of the wave equation, Schrödinger's beautiful equation, tells us something subtle and profound. The wave does not stop abruptly at the wall. It does not cut off like a cliff. Instead, it penetrates the barrier. Imagine the wave hitting the wall. Inside the wall, the wave function does not become zero immediately. It becomes an evanescent wave, a ghostly tail that decays exponentially. It gets weaker and weaker the deeper it goes into the wall, but it does not vanish completely. If the wall is thin enough, or if the barrier is narrow enough, that ghostly tail can actually reach the other side. And if the wave reaches the other side, there is a non-zero probability, a real, tangible chance, that the particle will be found there. It does not drill a hole. It does not smash through. It simply transitions from a state of being on this side to a state of being on that side, without ever truly existing in the middle. It tunnels through the impossible. This sounds like magic. It sounds like a cheat code for the universe, but it is the only reason the stars shine. Let us travel to the center of our sun. It is a place of unimaginable violence and pressure. The temperature is 15 million degrees Kelvin. The density is 150 times that of water. In this crushing inferno, hydrogen atoms are stripped of their electrons, leaving bare protons to tumble and crash into each other. For the sun to generate energy, for it to shine and give life to Earth, these protons must fuse together to form helium. This is nuclear fusion. It is the heartbeat of the cosmos. But there is a problem. Protons are positively charged. And as we know from high school physics, like charges repel, this is the Coulomb barrier. It is an electromagnetic force field that surrounds every proton, shouting, "Stay away," to every other proton. For two protons to fuse, they must get close enough for the strong nuclear force, the Velcro of the universe, to snap them together. But The strong force is short range. It only works when the protons are practically touching. To get that close, the protons must be moving fast enough to overcome the electromagnetic repulsion. They need immense kinetic energy. They need to be hot. Here is the shocking truth. The center of the sun is not hot enough. 15 million degrees is hot, but it is not fusion hot. To overcome the Coulomb barrier purely by classical force, the sun would need to be billions of degrees hotter. If the universe ran on classical mechanics, the sun would be dark. It would be a cold, dead ball of gas. The protons would rush toward each other, feel the repulsion, and bounce off like marbles hitting a glass jar. No fusion, no light, no heat, no life on Earth. We would not exist. So why is the sun shining? Because of tunneling. The protons in the core are quantum objects. They are waves. As two protons race toward each other, they hit the electromagnetic wall of repulsion. They do not have the energy to climb over it. They should turn back. But their wave functions overlap. The tail of one proton's wave sinks into the barrier of the other, and every once in a while, a very, very rare once in a while, the impossible happens. The proton defies the energy deficit. It tunnels through the Coulomb barrier and finds itself in the embrace of the other proton. The strong force snaps shut. Fusion occurs. A tiny burst of energy is released. This event is incredibly unlikely for any single proton. The chance of a specific proton tunneling and fusing is something like 1 in 10 to the power of 28. It is like winning the lottery 1 billion times in a row. A single proton in the sun could wait billions of years before it tunnels. But the sun is huge. It contains vast numbers of protons, about 10 to the power of 57. Because there are so many of them, this rare event happens countless times every second. The collective tunneling of octillions of protons generates the blinding light that bathes our planet. The warmth on your skin is the heat of quantum tunneling. You are being tanned by probability. You're being warmed by the ghost in the machine. But tunneling is not just something that happens in the stars. It is happening inside you, right now. Your body is a quantum machine. The enzymes that digest your food, the proteins that repair your DNA, the chemical reactions that fire in your brain. Many of these rely on proton tunneling. In biological reactions, hydrogen ions, protons, often need to move from one molecule to another. Often, there is an energy barrier, a chemical mountain, that is too high for them to climb at body temperature. If they had to wait for enough thermal energy to jump over, the reactions would be too slow. You would die. You would freeze in time. But evolution has found the loophole. Enzymes are shaped in such a way that they bring the molecules close together, narrowing the barrier. They create the perfect conditions for the proton to tunnel. The proton vanishes from the donor molecule and reappears on the acceptor molecule, skipping the mountain entirely. This speeds up reaction rates by a factor of up to 1 trillion. The speed of life is the speed of tunneling. Your thoughts, your digestion, your very breath, they are all powered by particles walking through walls. There is even a theory that mutations, the drivers of evolution itself, can be caused by tunneling. The DNA molecule is a double helix held together by hydrogen bonds. These bonds involve protons sitting in specific positions. But sometimes, a proton can tunnel to the wrong side of the bond. It can jump the barrier. If the DNA strand unzips and replicates while the proton is in this wrong position, it pairs with the wrong base. A letter in the genetic code is changed. a mutation occurs. It is possible that the variation of life on Earth, the diversity of species from bacteria to blue whales to you, is partly due to the quantum restlessness of protons. We are the children of the tunnel. Consider our technology. If you have a USB drive or an SSD in your computer, you are using trapped electrons to store information. Flash memory works by trapping electrons inside a microscopic cage, a floating gate, separated from the rest of the circuit by a thin oxide wall. The wall is too high for the electrons to escape classically. They are locked in. This is your data, your photos, your documents, your memories. But to erase the data or to write new data, we apply a voltage that tilts the barrier, making it thinner. The electrons tunnel through the oxide layer, entering or leaving the cage. Every time you save a file, you are commanding billions of electrons to perform a magic trick. You are the wizard of the barrier. Or consider the scanning tunneling microscope, STM, a device so sensitive it can image individual atoms. It works by bringing a sharp metal tip, just 1 atom wide, incredibly close to a surface. It does not touch the surface. It hovers. A voltage is applied. Electrons do not have the energy to jump the gap. But because the gap is so small, they tunnel across the vacuum from the tip to the surface. By measuring this tunneling current, we can map the bumps and valleys of the atomic landscape. We can see the atoms because they are leaking their probability across the gap. We are touching the ghost of the surface. What does this mean for our philosophy of life? It changes how we view the concept of impossible. In the classical view, if you lack the energy, the door is shut. The outcome is zero. But in the quantum view, there is no such thing as zero probability. There is only low probability. The wave function never truly disappears. It just gets very, very small. This means that, in principle, there is always a chance to overcome a barrier, no matter how high. It means that the hard constraints of reality are actually soft probabilities. Think about the barriers in your own mind, the habits you cannot break, the fear that holds you back, the belief that you are not strong enough, smart enough, or brave enough to reach the other side. You look at the obstacle and you see a solid wall. You calculate your energy and you come up short. But you are not a classical object. You are a complex system of quantum events. Your brain is a storm of tunneling electrons and ions. The very structure of your thoughts allows for discontinuous jumps. Insight, that sudden aha moment where the answer appears out of nowhere, feels remarkably like tunneling. You were stuck on one side of the problem, and then, without crossing the intermediate steps, you were suddenly on the other side, holding the solution. Perhaps hope is a kind of tunneling. Perhaps faith is the intuition that the barrier is not as solid as it looks. When we persevere against impossible odds, when we keep pushing against a wall that will not move, maybe we are waiting for that quantum moment where the wave function aligns and we slip through. The universe tells us that patience and persistence change the odds. The proton in the sun waits billions of years, but eventually it fuses, it shines, it fulfills its destiny. We are surrounded by barriers, the barrier between you and another person, the impossibility of truly knowing someone else's mind, the barrier between the present and the future, the barrier between life and death. We see these as absolute walls, but the quantum perspective suggests that the separation is not total. There is leakage. There is resonance. The wave of your life extends beyond the boundaries of your body and your moment. You are touching things you cannot see. You are influencing events on the other side of the wall. So, tonight, as you close your eyes, Imagine the walls of your room. They look solid. They feel hard. But you know now that they are made of atoms that are mostly empty space, held together by fields of force. And you know that the particles in those walls are tunneling, vibrating, exploring the space. The solidity is a persistent illusion. And then, turn that gaze inward. Look at the walls inside you, the I can't, the it's too late, Ted, the I'm not enough. See them for what they are, energy barriers, high, yes, daunting, yes, but not absolute. You are a creature of the wave. You have a tail of probability that extends past your limitations. You are already, in some small but real sense, on the other side of the mountain. You are already standing in the future you desire. The connection is made. The tunnel is open. You just need to wait for the moment of transition. The sun is shining on the other side of the earth right now, powered by the impossible. The stars are burning in the cold void, powered by the impossible. Your heart is beating. Your cells are breathing. Your mind is dreaming, all powered by the impossible. You are the impossible happening over and over again. You are the miracle of the tunnel. And as we drift further into this strange night, we must ask, if matter can walk through walls, and if particles can be in two places at once, what is the empty space they are moving through? Is the vacuum truly empty? Or is it a seething ocean of hidden energy, a place where particles are born from nothing and return to nothing in the blink of an eye? In the next chapter, we will dive into the void. We will explore the Heisenberg uncertainty principle, not as a limit on knowledge, but as a license for creation. We will find that nothing is the most heavy, potent, and alive thing in the universe. We are going to meet the virtual particles. We are going to find out that you are never, ever in a truly empty room. Rest now. Let your thoughts tunnel through the dark. Let your worries hit the wall and vanish. Let your dreams slip through the barrier. You are safe in the quantum night. You are infinite. You are free. Have you ever sat in a room so quiet that the silence began to feel heavy? A silence so deep that it wasn't just an absence of noise, but a presence in itself? We tend to think of silence, of emptiness, of the void, as a lack. We think of a vacuum as a space where nothing exists, a blank canvas waiting for paint, a stage waiting for actors. If you take a box and pump every single atom of air out of it, shield it from all light, block every radio wave, and cool it down to absolute zero, common sense tells you that the box is empty. It contains nothing. It is a dead zone. But the quantum universe, in its infinite restlessness, disagrees. It tells us that there is no such thing as truly empty space. It tells us that the vacuum is not a void. It is a plenum. It is a seething, boiling, violent ocean of energy that is constantly creating and destroying itself in every fraction of a second. The silence is not empty. The silence is full. To understand this, we must meet one of the titans of quantum mechanics, Werner Heisenberg. You might know him for his famous uncertainty principle. Often, this principle is explained as a limit on measurement. You cannot know the position and the momentum of a particle at the same time with perfect precision. If you know exactly where an electron is, you have no idea how fast it is moving. If you know how fast it is moving, you have no idea where it is. It sounds like a problem with our rulers, a clumsiness of our hands. But Heisenberg's discovery was far more profound than just a measurement problem. He revealed that nature itself is fuzzy. Nature does not have a precise position and momentum simultaneously. It is a trade-off. It is a bargain. But there is another version of this uncertainty, one that applies to energy and time. The equation looks similar. The uncertainty in energy multiplied by the uncertainty in time must be greater than a tiny constant. This sounds abstract, but its implication is magical. It means that for very, very short periods of time, the law of conservation of energy, the strict rule that says energy cannot be created or destroyed, can be broken. The universe allows you to borrow energy from absolutely nothing, as long as you pay it back quickly. The more energy you borrow, the faster you have to return it. It is like a cosmic bank with a very strict overdraft policy. So, let us look at that empty box again. In the classical view, there is zero energy inside. But in the quantum view, because the time interval we are looking at is tiny, the energy uncertainty can be huge. In every cubic centimeter of that empty space, pairs of particles are constantly popping into existence. A particle of matter and a particle of antimatter, say an electron and a positron, suddenly materialize out of the void. They borrow the energy for their existence from the vacuum itself. They exist for a fleeting instant, perhaps a trillionth of a nanosecond, and then they crash back together. They annihilate. They return the energy to the bank. They vanish. These are called virtual particles. They are the ghosts of the quantum world. They are not real in the sense that they can trigger a Geiger counter and stay there, but they are real in their effects. They are happening everywhere, all the time. Right now, in the empty space between your eyes and this screen, trillions of virtual particles are flashing in and out of existence. The air is not just air. It is a foam of quantum potential. The vacuum is alive. It is a frothing sea of creation and destruction. You are walking through a storm of ghosts every moment of your life. How do we know this isn't just a mathematical fantasy? How do we know these virtual particles are real? Because we can feel them pushing. In 1948, a Dutch physicist named Hendrik Casimir predicted a strange effect. He said that if you take two uncharged metal plates and place them incredibly close together in a vacuum, closer than a micron, they will be pushed together by a mysterious force. They will stick. Why? Because of the virtual particles. Imagine the vacuum as a sea of waves of all different sizes. Outside the plates, in the open space, waves of all wavelengths can fit. Big waves, small waves, tiny ripples. They are all pushing on the outside of the plates. But between the plates, the space is tight. Only small waves that fit in the gap can exist there. The big waves are excluded. This means there are fewer virtual particles pushing out from the inside than there are pushing in from the outside. The pressure of the nothing outside is greater than the pressure of the nothing inside. The plates are crushed together by the sheer weight of the empty space. This is the Casimir effect. It has been measured in the lab. It is real. We have measured the force of the void. We have weighed the nothingness. This realization changes everything about how we view the cosmos. It means that nothing is actually the most heavy, potent thing in the universe. Some calculations suggest that the energy density of the vacuum is enormous, so huge that a coffee cup of empty space contains enough energy to boil all the oceans on Earth. This is the zero-point energy. It is the energy that remains when everything else is removed. It is the hum of the universe that never goes silent. And this leads us to one of the most beautiful and tragic phenomena in astrophysics, the death of black holes. Stephen Hawking, the brilliant physicist who spent his life in a wheelchair exploring the deepest reaches of the mind, used the idea of virtual particles to prove that black holes are not truly black. Imagine the event horizon of a black hole, the point of no return. It is a sharp edge in space. On one side you are safe. On the other, you are lost forever to gravity. Now, imagine a pair of virtual particles popping into existence right on this edge. An electron and a positron. Usually they would snap back together and vanish. But here, gravity is steep. It is possible that one particle falls into the black hole, while the other escapes into space. The one that falls in is lost. The one that escapes becomes a real particle. It has no partner to annihilate with. It flies away as radiation. To an observer far away, it looks like the black hole is glowing. It looks like it is emitting heat. This is Hawking radiation. But here is the cost. The energy to create that escaping particle had to come from somewhere. It came from the black hole itself. The particle that fell in effectively has negative energy relative to the outside universe. It subtracts mass from the black hole. So, as the black hole glows, it loses weight. It shrinks. Over unfathomable eons, as it emits these lonely survivors of the vacuum, the black hole evaporates. It gives its mass back to the universe, one virtual particle at a time. Eventually, after trillions of years, it will explode and vanish. The mightiest monsters in the cosmos are slowly being eaten by the nothingness. They are dissolving into the quantum foam. This paints a picture of the universe that is profoundly organic. The vacuum is not a sterile container. It is a soil. It is a garden. Particles are the flowers that bloom from this soil, fueled by the borrowed energy of the uncertainty principle. We are, in a sense, just excitations of the vacuum. We are rare, stable ripples on the surface of a deep, chaotic ocean. When we die, our atoms return to the cycle, but the energy that sustained us, the fundamental field, remains. There is a deep comfort in this. It means that isolation is an illusion. You cannot be separated from the universe because the space between you and the rest of the world is not empty. It is a bridge. It is a connector. It is a living medium. The silence you feel in a lonely room is not an absence of life. It is the presence of potential. It is the hum of the engine that drives all existence. Think about the thoughts in your own mind. Where do they come from? They often appear like virtual particles popping into existence from the void of your subconscious. You do not always build them brick by brick. Sometimes they just arrive. A flash of inspiration, a sudden memory, a new idea. Perhaps consciousness itself operates on the edge of this quantum uncertainty, borrowing energy from the void to create meaning. Perhaps our minds are just the Casimir effect of the soul, pulling ideas out of the pressure of the nothing. The Heisenberg uncertainty principle is often taught as a limit, a barrier to knowledge, but I prefer to see it as a liberty. It is a license for the universe to be creative. If the universe were perfectly precise, if every particle had a fixed position and momentum, if energy were strictly conserved at every instant, it would be a clockwork machine. It would be frozen. It would be dead. It is the fuzziness, the blur, the uncertainty that allows for change. It is the wiggle room that allows the proton to tunnel. It is the debt limit that allows the virtual particle to pop up. Uncertainty is the breathing room of reality. It is the crack in the wall where the light gets in. So, the next time you feel empty, the next time you feel drained or hollow, remember the vacuum. Remember that in the quantum world, emptiness is just energy waiting to happen. You are never truly running on empty. You are running on the zero-point field. You are sitting on a reservoir of infinite potential. The feeling of nothing is just the feeling of everything before it takes form. We have explored the void, and we have found it full. We have explored the walls and found them permeable. We have explored time and found it fluid. But there is one more frontier we must cross, one that brings all this strangeness home to the warm, wet, messy world of biology. For a long time, scientists thought quantum mechanics only mattered for isolated atoms in cold labs. They thought living things were too hot and wet to sustain quantum effects. They thought life was strictly classical. But they were wrong. In the next chapter, we are going to discover that you are a quantum superhero. We are going to learn that birds use quantum entanglement to see the magnetic field of the Earth. We are going to learn that plants use quantum coherence to eat sunlight. We are going to learn that your sense of smell might be detecting the vibrations of molecules, not just their shape. We are going to enter the new and exploding field of quantum biology. We are going to find out that life is the master of the quantum realm, surfing the waves of probability to survive. But for now, rest in the fullness of the silence. Listen to the quiet of the room. It is the sound of the universe breathing. It is the sound of particles being born and dying in a dance that has no end. You are part of that dance. You are the music and the silence. You are the vacuum and the star. Have you ever watched a small bird in the autumn sky, beating its wings against the wind, setting off on a journey that spans thousands of miles? Every year, the European robin migrates from the cold north to the warm south. It flies over oceans it has never seen, over forests it does not know, through storms and silence, and it arrives at a specific tree in a specific garden with the precision of a laser-guided missile. For centuries, we thought we understood how they did it. We thought they were just following the sun, or perhaps recognizing landmarks, or sensing the pull of the Earth's magnetic field like a simple compass needle. We assumed that biology was a wet, warm, messy business, governed by the laws of classical chemistry and Newtonian mechanics. We assumed that the delicate, ghostly effects of quantum physics, entanglement, superposition, tunneling, could only survive in the deep freeze of a laboratory vacuum, isolated from the chaotic noise of living cells. We were wrong. We are about to enter the lush, green, vibrating world of quantum biology. We are about to discover that life, in its infinite wisdom, has learned to harness the strange laws of the subatomic world to survive. The robin is not just a bird, it is a flying quantum computer. Inside the eye of that tiny creature, something miraculous is happening. When a photon of blue light enters the bird's eye, it strikes a protein called cryptochrome. This collision knocks an electron loose, creating a pair of molecules with unpaired electrons, known as a radical pair. These two electrons are entangled. They are linked by that spooky action at a distance we discussed earlier. As the bird flies through the Earth's magnetic field, the tiny, weak magnetic pull of the planet interacts with the spin of these entangled electrons. Because they are entangled, the state of one affects the state of the other instantly. The Earth's field tilts the balance of the reaction between a singlet state and a triplet state. This chemical shift sends a signal to the bird's brain. It allows the robin to literally see the magnetic field lines as a pattern of light and shadow superimposed over its vision. The bird is navigating by reading the quantum entanglement in its own retina. It is surfing the wave of probability to find its way home. If you disrupt the entanglement, the bird gets lost. Life has built a compass out of the spookiest phenomenon in the universe, but the bird is not alone. Look at the green leaf of a houseplant sitting on your windowsill. It looks still. It looks simple. It is just soaking up the sun. But inside every cell of that leaf A quantum dance is taking place that defies the logic of classical efficiency. When a photon of sunlight hits a chlorophyll molecule, it creates a packet of energy called an exciton. This energy needs to travel to a reaction center, a specific spot where it can be converted into chemical food before it fades away. In the classical world, the exciton would have to bounce around randomly, like a pinball hitting bumpers, hoping to find the hole. It would lose energy with every bounce. It would generate heat. It would be inefficient. If photosynthesis worked this way, plants would be terrible at eating sunlight. They would starve. But they do not. Photosynthesis is almost 100% efficient. Almost every single photon that is absorbed reaches the reaction center. How? Because the exciton does not bounce. It behaves like a quantum wave. It enters a state of superposition. It takes all possible paths to the reaction center at the same time. It flows through the complex maze of the protein structure, like water flooding a network of canals. It finds the shortest, most efficient path instantly, simply by trying them all simultaneously. This is called quantum coherence. It is the same principle that allows quantum computers to crack codes, but it is happening in a fern, in a blade of grass, in the algae floating on a pond. The plants are performing quantum computations every split second to feed themselves. They are harvesting the sun using the uncertainty principle. The green world is a quantum world. And what about you? What about your own experience? Take a deep breath through your nose. Maybe you smell coffee or rain or the scent of an old book. For decades, scientists believed that smell worked like a lock and a key. They thought that a scent molecule had a specific shape, and it fit into a receptor in your nose that had the matching shape. If the shape fit, the receptor fired, and you smelled a rose. This is the shape theory. It makes sense. It is intuitive. But it has a problem. There are molecules that have completely different shapes, but smell exactly the same. And there are molecules that have the exact same shape, mirror images of each other, but smell completely different. One might smell like oranges, and its mirror twin smells like turpentine. If shape were everything, this should not happen. Enter the vibration theory of olfaction, proposed by the biophysicist Luca Turin. He suggests that our noses are not just checking the shape of the molecule. They are listening to it. Chemical bonds vibrate. They hum at specific frequencies. A bond between carbon and hydrogen vibrates at a different pitch than a bond between carbon and sulfur. Turin proposed that when a scent molecule docks in your receptor, an electron tries to tunnel across the molecule to the other side of the receptor. But to do this, the electron needs to lose a specific amount of energy. It can only lose that energy if the molecule in the middle is vibrating at the exact right frequency to absorb it. The molecule acts like a bridge. If the song is right, the electron tunnels. The receptor fires. You smell the rose. If this is true, and experiments are mounting to support it, then your nose is a spectroscope. It is a quantum device that detects the vibrational frequency of atoms by using electron tunneling. You are smelling the quantum music of the universe. You're sniffing the vibrations of the bonds. The scent of a loved one is a quantum symphony played on the instrument of your olfactory bulb. This realization that life is inherently quantum shatters the old divide between the dead world of physics and the living world of biology. We used to think that life was something that happened on top of physics, a layer of complexity added to the cold laws of matter. But now we see that life goes all the way down. Life has dug its roots into the bedrock of reality. It has learned to play the quantum game better than any machine we have ever built. Think about the implications of this. We are usually told that quantum states are fragile, that they collapse the moment they are touched by heat or noise. This is called decoherence. It is the enemy of quantum computers. To build a quantum computer, we have to cool it to near absolute zero and shield it from everything. And yet, life is warm. Life is wet. Life is noisy. A bird's eye is not a vacuum chamber. A leaf is not a freezer. And yet, quantum coherence survives there. Life has found a way to protect the signal from the noise. It has found a way to maintain the ghost in the machine, to keep the wave function dancing in the middle of a hot, chaotic soup. This suggests that life is not just a chemical accident. It suggests that life is a phenomenon that resonates with the fundamental structure of the universe. We are not separate from the quantum foam. We are an extension of it. We are the universe finding a way to sustain its own complexity. We are the way the cosmos surfs its own waves. Consider the enzymes in your body again. We talked about how they use tunneling to speed up reactions. But recent research suggests they might use entanglement too. Some studies on the magnetic sense of fruit flies and even the chemical reactions in our own mitochondria hint at quantum correlations. Keeping our metabolism running, you are burning energy right now using principles that Einstein found spooky. You are keeping your body temperature at 37 degrees Celsius by cheating the classical laws of probability. This changes the way we look at nature. When you walk through a forest, you're not just walking through a collection of biological machines. You are walking through a field of quantum computation. The trees are calculating the sunlight. The birds are calculating the magnetic field. The insects are calculating the vibrations of the air. The forest is humming with a processing power that dwarfs the internet. It is a silent, green supercomputer solving the problem of survival using the laws of the subatomic void. And what about the greatest mystery of all? What about the thing that is allowing you to understand these words right now? What about your mind? For centuries, we have tried to explain consciousness. We have looked at neurons firing, at synapses connecting, at chemicals flowing. We have compared the brain to a telephone switchboard, then to a computer, then to the internet. But none of these models quite fit. They explain the processing, but they do not explain the feeling. They do not explain the subjective experience of being, the redness of red, the sadness of grief, the spark of an idea. Is it possible that the brain, the most complex object in the known universe, is also a quantum machine? Is it possible that the wet gray sponge inside your skull is utilizing the same principles as the robin's eye and the green leaf? In the 1990s, the physicist Roger Penrose and the anesthesiologist Stuart Hameroff proposed a radical theory. They suggested that consciousness does not arise from the connections between neurons, but from deeper inside, within the tiny structural skeletons of the cells called microtubules. They proposed that these microtubules act as quantum cavities, trapping and protecting quantum states. They suggested that the brain is orchestrating a massive, unified quantum state, a collapse of the wave function that happens millions of times a second, and that each collapse is a moment of conscious awareness. This theory, called orchestrated objective reduction, was mocked for years. The brain is too warm, critics said. Decoherence would kill the quantum state instantly. But then came the discoveries in the birds. Then came the discoveries in the plants. We learned that life can protect quantum states in warm environments, and suddenly the idea of the quantum brain does not seem so impossible. If a leaf can hold a superposition for a picosecond to eat the sun, why can't a neuron hold a superposition to generate a thought? Imagine if your thoughts are not just electrical impulses, but quantum events. Imagine if your mind is a non-local field capable of entanglement, capable of tunneling, capable of resonating with the universe in ways we have not yet dared to dream. It would explain why intuition feels like a leap. It would explain why we feel connected to each other. It would explain why the observer effect is so powerful. We are standing on the edge of a new biology, a biology that includes the soul of the atom. We are realizing that we are not just meat and bone. We are stardust organized by quantum logic. We are the universe waking up to its own potential. As you sit here, breathing, smelling, seeing, thinking, you are performing a miracle of physics. You are a symphony of the very small, playing out on the scale of the very large. You are the bridge between the quantum and the classical. You are the place where the ghost becomes the machine, and the machine becomes the spirit. Feel the heat of your body. That is the fire of tunneling. Feel the light entering your eyes. That is the entanglement of electrons. Feel the flow of your thoughts. That might be the collapse of the wave function itself. You are not an observer separate from the experiment. You are the experiment. You are the quantum cat, alive and watching, collapsing reality with every beat of your heart. And as we prepare to close this chapter, we must ask the final, most dangerous question. If our brains are quantum machines, and if quantum mechanics allows for connections across time and space, is consciousness confined to the brain at all? Does the mind end at the skull? Or is the brain just a receiver for a signal that permeates the entire cosmos? In the next chapter, we are going to explore the quantum mind. We are going to ask if consciousness is fundamental, if it is not something the universe does, but something the universe is. We are going to look at the edge of death, the nature of memory, and the possibility that your awareness is as old as the Big Bang itself. Rest in your biological wonder. Rest in the knowledge that you are smarter than you know, deeper than you feel, and more connected than you can imagine. You are the robin finding its way home. You are the leaf eating the light. You are the quantum mystery in human form. Have you ever looked into a mirror, locked eyes with your own reflection, and felt a sudden, vertigo-inducing jolt of strangeness? For a moment, the face looking back at you seems alien. You ask yourself, who is this? Who is the I that is asking the question? You are the only thing in the universe that you can be absolutely certain exists. You know you are here. You know you are feeling. You know you are aware. And yet, this undeniable fact, your own consciousness, is the single greatest mystery in all of science. We can map the galaxies to the edge of the visible universe. We can smash atoms to reveal the quarks hiding inside. We can edit the genetic code of life. But we cannot explain how a 3-pound lump of wet, gray biological matter produces the feeling of being alive. We cannot explain the redness of a rose, the ache of heartbreak, or the taste of cold water on a hot day. These are subjective experiences, what philosophers call qualia, and they do not appear anywhere in the equations of physics. In the classical view, your brain is just a computer made of meat. It processes input and produces output. But a computer does not feel the data it processes. A calculator does not enjoy the elegance of an equation. A camera does not admire the sunset it captures. Why do you? Why is there a ghost in the machine? We are about to embark on the most daring leg of our journey. We are going to explore the possibility that consciousness is not an accidental byproduct of evolution, but a fundamental property of the universe itself. We are going to ask if the mind is a quantum field. To do this, we must return to the intersection of the very small and the very large. In the previous chapter, we touched on the idea of microtubules, the tiny structural scaffolds inside your neurons. We mentioned the theory of orchestrated objective reduction, or ORC-OR, proposed by the Nobel laureate Roger Penrose and Stuart Hameroff. Now, we must dive deep into what this theory actually implies about the nature of your soul. Penrose, a man who spent his life studying the geometry of the universe, believes that classical physics, the physics of billiard balls and planets, can never explain consciousness. Computation, he argues, is algorithmic. It follows a set of rules. But human understanding is non-algorithmic. We can see truths that cannot be proven by rules. We have insight. We have intuition. Therefore, the brain cannot simply be a classical computer. It must be using something else. It must be using the only physics we know that allows for non-computable outcomes, quantum mechanics. The theory suggests that inside the dark, warm tubes of the microtubules, quantum superpositions are being isolated. Tubulin proteins exist in two states at once. They are calculating, vibrating, and exploring possibilities in the quantum realm. But here is the radical part. In standard quantum mechanics, the wave function collapses when it is observed by an outside environment. But Penrose suggests that if a system is isolated enough, it will eventually collapse on its own, due to the instability of space-time itself. When a particle is in two places at once, it is effectively warping gravity in two different ways simultaneously. The fabric of space-time can only tolerate this separation for so long before it snaps back into a single state. This snap is a moment of objective reduction, and here is the beautiful, terrifying hypothesis. Every time this snap occurs, every time the wave function collapses due to its own gravitational weight, a tiny spark of proto-consciousness is released. A moment of pure experience occurs. It is a bing of existence. In a single electron, this bing is unimaginably simple, perhaps just a flicker of raw existence. But in the brain, millions of these collapses are orchestrated together every second. The microtubules organize them into a symphony. The bings fuse together to form the stream of consciousness that is you. Your mind is not a continuous entity. It is a rapid-fire sequence of quantum moments, stitched together like the frames of a movie, creating the illusion of a continuous flow. You are a rhythm of the universe, collapsing into reality, over and over again. If this is true, it overturns everything we think we know about matter and spirit. It implies that consciousness is not something the brain creates. It is something the brain accesses. The ingredients for consciousness, those tiny moments of objective reduction, are happening everywhere in the universe. They are happening in the air, in the rocks, in the heart of the sun. But in those places, the moments are random, disjointed, and fleeting. They do not form a self. They are just a low-level hum of proto-experience. The brain is not a generator of mind. It is a receiver. It is an antenna. It is a finely tuned instrument designed to capture these fundamental quantum events and weave them into a coherent story. Think about a radio. If you smash a radio with a hammer, the music stops. A primitive observer might conclude that the radio was creating the music, And now that the machine is broken, the music is dead. But we know better. We know the radio was just tuning into a signal that exists in the air, independent of the device. If the brain is a quantum radio, then the destruction of the brain, death itself, might not be the end of the consciousness. It might just be the breaking of the receiver. The signal, the fundamental quantum information that made up your self, might return to the background field of the universe. This aligns with the deepest intuitions of humanity across every culture and every age. We have always felt that we are more than our bodies. We have always felt a connection to a larger whole. This theory gives that feeling a foothold in physics. It suggests a version of panpsychism, the idea that mind is everywhere. It suggests that the universe is not a cold, dead stage where life accidentally appeared. It suggests that the universe is awake. It is humming with an inner life that becomes more complex, more vivid, and more self-aware as matter organizes itself into biology. We are the universe looking at itself through a lens of quantum biology. This perspective also sheds light on the mysterious experiences reported by people who have come close to death. Millions of people have reported near-death experiences, or NDEs. They speak of leaving their bodies, of seeing a tunnel of light, of meeting lost loved ones, of experiencing a sense of infinite love and knowledge. For a long time, science dismissed these as hallucinations of a dying brain, the chaotic firing of neurons starved of oxygen, and perhaps some of them are. But the quantum theory of consciousness offers a different possibility. When the metabolic activity of the brain slows down near death, the noise decreases. The classical interference fades. It is possible that as the biological hold on the quantum state loosens, the consciousness does not vanish, but expands. If the self is a pattern of entanglement, and if entanglement is non-local, then as the local constraints of the body fall away, the mind might regain its connection to the non-local universe. The tunnel might be a visceral experience of quantum tunneling. The light might be the perception of the zero-point energy field. The sense of oneness might be a direct experience of the entanglement that binds all things. This is speculation, of course. We are standing on the very edge of the map where science fades into philosophy, but it is speculation grounded in the equations of the cosmos. It asks us to consider that our limited perception of here and now, of me and you, is a biological filter. The brain's job is to reduce the infinite amount of information in the universe down to a manageable trickle that helps us survive. It filters out the cosmic noise so we can focus on finding food and avoiding predators. But at the moment of death, the filter breaks, the dam bursts, and the ocean rushes in. Imagine if your memories are not stored in the synapses of your brain like files on a hard drive, but are holographically encoded in the structure of space-time itself. There is a concept in physics called the holographic principle, which suggests that all the information in a volume of space can be stored on its boundary. If the brain utilizes this principle, then your memories are not in your head. Your head is just the device that retrieves them from the cloud of the cosmos. This would explain why memory is so resilient, why it can survive damage to the brain, and why it sometimes feels so vivid, as if we are reliving the moment rather than just recalling it. We are accessing the eternal block of space-time where the past still exists. This view of the quantum mind also reframes our understanding of mental health and human connection. If we are all resonant quantum systems, then empathy is not just a psychological projection. It is a physical resonance. When you feel someone else's pain, your microtubules might be vibrating in sympathy with theirs, connected by the subtle threads of entanglement that link us all. We are like tuning forks. When one is struck, the others hum. Depression might be a loss of quantum coherence, a dampening of the music, a disconnect from the field. Joy might be a state of high resonance, a perfect harmony between the internal state and the external world. And what of the future? If consciousness is fundamental, then the evolution of the universe has a direction. It is moving toward greater complexity, greater entanglement, greater awareness. We are not just drifting in a purposeless void. We are the spearhead of a cosmic process. We are the universe trying to wake up more fully. Every time you learn something new, every time you love, every time you create art, you are increasing the coherence of the cosmos. You are adding to the complexity of the quantum field. You are doing the universe's work. This implies that you are far more ancient than your birth certificate says. The atoms in your body were forged in stars, yes. But the potential for your consciousness, the fundamental being of experience, has been woven into the geometry of space-time since the Big Bang. You are a localized expression of an eternal capacity for awareness. The specific pattern of you is new, but the stuff you are made of, the matter and the mind, is as old as time. As you lie here, floating in the quiet, try to feel that ancientness. Try to feel the hum of the quantum field inside your own skull. You're not a stranger in the universe. You're not an intruder. You're a native. You belong here. Your consciousness is just as much a part of the natural world as gravity, or electromagnetism, or light. You are a feature of the cosmos, not a bug. This realization brings a profound peace. It takes the weight of existence off your shoulders. You do not have to create meaning. You are meaning. You do not have to earn your place. You are the place. You are the universe experiencing itself from a unique, unrepeatable perspective. And when this brief ride is over, when the biological receiver inevitably fails, the signal does not have to end. The music continues. The wave function returns to the ocean, enriched by the journey it took as you. In the classical world, death is a wall. In the quantum world, death is a tunnel. It is a phase transition. It is the moment where the particle becomes the wave again. It is the moment where the drop falls back into the sea and realizes it was water all along. So, let the mystery of your own mind be a comfort, not a worry. You are a quantum miracle. You are a walking, talking galaxy of complex interactions. And, as we prepare for the final chapter of our journey, we must look at the ultimate horizon. We have looked at the beginning of the universe, and we have looked at the center of the self. Now, we must look at the end. What is the ultimate fate of this quantum cosmos? If everything is entangled, if time is a loop, if consciousness is fundamental, where is this all going? In the final chapter, we will explore the omega point. We will explore the concept of the cyclic universe. We will ask if the Big Bang was a beginning or a bounce. We will look at the heat, death, and we will find hope even in the cold dark. We are going to tie all the threads together, the light, the cat, the tunnel, the mind, into a single, unified tapestry of existence. We are going to finish the story where it began, in the heart of the mystery. But for now, just breathe. Feel the bing of the present moment. That tiny spark of awareness is the most precious thing in existence. It is the diamond in the dark. It is the proof that the universe is alive. You are here. You are now. And that is a miracle that defies all calculation. Rest in your own existence. Rest in the quantum mind. We have journeyed together from the microscopic emptiness inside an atom to the spooky connections that span the galaxy. We have walked through walls, traveled backward in time, and peered into the quantum machinery of a robin's eye. We have asked if a cat can be both dead and alive, and if our own souls are woven from the fabric of space-time. Now, we stand at the final precipice. We must look to the end of all things. If the universe began with a Big Bang 14 billion years ago, how will it end? The classical story of physics is a tragedy. It tells us that the universe is expanding and cooling. As the eons pass, the stars will burn through their fuel and wink out one by one. The galaxies will drift apart until they disappear from each other's view, carried away by the relentless expansion of space. The black holes will inherit the cosmos, swallowing the last remnants of matter, only to slowly evaporate into Hawking radiation over trillions of years. Eventually, the universe will reach a state of maximum entropy. It will be a cold, dark, uniform soup of particles, unable to do work, unable to support life, unable to think. This is the heat death. It is the ultimate silence. It is a terrifying vision of futility that suggests all our struggles, all our art, all our love will eventually amount to absolutely nothing in the face of the encroaching dark. But we have learned by now that the classical story is never the whole story. The quantum universe does not believe in endings. It believes in cycles. It believes in transformation. Just as a particle can vanish from one side of a barrier and appear on the other, just as a vacuum can boil with virtual life, the death of the universe might just be the most spectacular tunneling event of them all. We are about to explore a theory that turns the heat death into a new genesis. It is called conformal cyclic cosmology, proposed by the same Roger Penrose who theorized the quantum mind. It suggests that the end is literally the beginning. Imagine the universe in the far, far future. All the stars are gone. All the black holes have evaporated. There is nothing left but photons, particles of light, and gravitational waves. Matter, the heavy stuff that makes up you and me, has decayed or been swallowed. Now remember what we learned about light. Photons have no mass, and because they have no mass, they do not experience time. To a photon, the moment it is created and the moment it is absorbed are the same moment. It zips across the universe in an instant of its own perception. But there is another property of massless particles. They do not know what size is. Scale is meaningless to them. Without heavy particles to provide a reference, without a clock or a ruler made of atoms, there is no difference between a universe that is incredibly huge and a universe that is incredibly small. In this distant future, the universe is infinitely large and cold, but because it is filled only with scale-invariant radiation, it forgets how big it is. Mathematically, a universe that is infinitely expanded and empty looks identical to a universe that is infinitely compressed and hot. The geometry of the heat death is mathematically indistinguishable from the geometry of the Big Bang. The end of one aeon is the beginning of the next. The cold, stretched-out silence of the deep future suddenly, through a trick of quantum geometry, becomes the hot, dense singularity of a new Big Bang. The universe does not die. It bounces. It breathes. It undergoes a phase transition from the end of time back to the beginning of time. This means that our Big Bang, the moment of creation we revere, was not the start of everything. It was just the moment the previous universe forgot its size. It was the moment the phoenix rose from the ashes of a trillion-year-old cosmos. And it means that long after we are gone, long after the stars have faded, the universe will be born again. A new generation of stars will ignite. New galaxies will spin. New forms of life will emerge to look up at their sky and wonder where they came from. We are part of an infinite chain of being, an eternal heartbeat that has no beginning and no end. This idea resonates with the concept of the omega point, a philosophical idea that the universe is evolving toward a maximum level of complexity and consciousness. If the universe is a cycle, perhaps it is also a learning machine. Perhaps each aeon is slightly richer, slightly more complex, slightly more awake than the one before. We know that information is never truly lost in the quantum world. If the black holes evaporate, the information of everything they swallowed is returned to the universe in the radiation. Perhaps this information is carried over the bridge of the Big Bounce. Perhaps the physical laws of our universe, the specific mass of the electron, the strength of gravity, are fine-tuned by the memory of the previous universe. We might be living in a cosmos that is evolving just like a biological organism, refining itself over eons of birth and rebirth. So, let us weave the threads of our journey together into a final tapestry. We started with the emptiness of the atom. We found that you are mostly void, but that void is full of fields. We found that you are made of light, energy, and that you are connected to the furthest star by entanglement. We found that your choices collapse the wave function of history, and that your mind might be a quantum antenna tuned to the frequency of the cosmos. Now we see that the cosmos itself is an eternal, self-renewing entity. You are not an accident. You are not a random fluctuation in a dying box. You are a necessary part of the cycle. The consciousness you hold right now, that bing of awareness inside your microtubules, is the universe observing itself. And by observing itself, the universe becomes real. In the delayed choice experiment, we saw that looking now can define the past. Maybe, in a grand cosmic sense, the fact that we are here looking at the universe is what allows the Big Bang to have happened in the first place. This is the participatory anthropic principle. We are the eyes of the storm. We are the reason there is something rather than nothing. Think of the cat in the box again, but this time, the box is the entire universe. The universe is in a superposition of all possible histories, all possible laws, all possible futures. It is a blur of infinite potential. But then, inside the box, a tiny part of the system wakes up. You wake up. You open your eyes. You look around. And in that act of looking, you force the universe to decide. You force the chaos to become the stars. You force the probability to become the planet. You are the observer who opens the box from the inside. This is the ultimate secret of quantum physics. It is not just about atoms. It is about you. It is about the power of the witness. It tells us that we are co-creators of this reality. We are the artists painting on the canvas of space-time. Every thought you think, every act of kindness, every moment of wonder collapses a new reality into being. You are constantly tunneling through the barriers of the impossible, creating new futures that did not exist a moment ago. The despair of the heat death melts away when we view it through this lens. The cold dark is not a grave. It is a womb. It is the rest period before the next great adventure. The silence is necessary for the next song to be heard. And even if our specific memories, our names, our faces fade into the quantum foam, the fundamental fact of our existence, the energy, the information, the consciousness, can never be destroyed. It is woven into the hologram of the universe forever. So, tonight, as you drift toward sleep, let your mind expand one last time. Feel the boundaries of your body dissolving. Feel yourself tunneling out of the room, rising above the house, above the city, above the turning earth. See the solar system as a little spinning disk of light. See the Milky Way as a swirling spiral of dust and diamonds. See the web of galaxies stretching out like a vast glowing neural network. And then see the whole thing breathing, expanding and contracting, breathing in, breathing out, a cosmic lung, a cosmic heart. You are that heart. You are not just a passenger on the ship. You are the ocean. You are the deep, dark, beautiful mystery that has been playing hide-and-seek with itself for eternity. You found yourself in the mirror of the atom. You found yourself in the riddle of the light. You found yourself in the silence of the void. The only video you need to understand quantum physics is the video of your own life. You are the experiment. You are the data. You are the theory. And you are the proof. Do not be afraid of the uncertainty. Embrace it. Uncertainty is freedom. Uncertainty is potential. Uncertainty is the space where the new can be born. Let go of the need to be solid. Let go of the need to be fixed. Be a wave. Flow through the open doors. Interfere with the world in beautiful patterns. Entangle your heart with the people you love. And know with absolute scientific certainty that you are infinite. The journey does not end here. The science will continue. We will build better telescopes. We will build faster computers. We will dig deeper into the brain. We will find new particles and new forces. We will rewrite the textbooks 1,000 times. But the core truth will remain. The universe is a single, unified, conscious thing. And you are it. Thank you for taking this journey into the quantum night. Thank you for collapsing the wave function of this video by watching it. Thank you for being the observer. The stars are waiting for you. The future is waiting for you. And the past is smiling at you. Sleep well, quantum traveler. The universe is dreaming of you.